Hello students. Moving on to the last part of the chapter friction, that is fluid friction, we'll understand the concept with the help of an activity. These two bottles contain two different type of liquids. I am dropping a small spherical ball in the liquids one by one. You see how long it takes to travel through each ball. The first ball, I'll drop one ball once again in the first bottle. See, it goes very quickly. Now I am taking one more ball and I am dropping it in the second liquid. And see, it goes a little slower. Looking at the same activity in slow motion. Have a look how long it takes. So we saw in the activity that the balls which were dropped in two different liquids, they took different times to fall through the liquid. The ball which was dropped in the denser liquid, that was actually a concentrated soap solution, the brown colored solution. It was a soap solution, concentrated one, in which the ball took a longer time to fall. So what is that which is stopping the ball from falling down faster as it was falling down through the clear water? So it is known as fluid friction, or the friction which is offered by fluids is known as drag or viscous force also. So what are the three different names of fluid friction? We call it either fluid friction, or we call it drag, or we call it viscous force. So this is a property of fluids that whatever object passes through the fluid, it opposes the motion of that object, and that opposition is known as viscous drag or fluid friction or drag. So what are the factors on which this force depends? This force depends upon, number one, the density of fluid. Which was shown in the activity, that the ball drops faster through the fluid which has a lesser density. Lesser the density, faster will the ball move, and it means that the lesser is the drag. So drag will be more if the density of fluid is more. The second factor on which it depends is the speed of the object. Faster the object moves, more will be the drag on it. For example, if you compare the drag experienced by a bicycle and a similar dimension motorbike which is moving at a faster speed, so the drag experienced by motorbike will be more. So it depends upon speed of the object also. The third factor on which it depends is shape of the object. I have seen several times on the roads while going, I have seen that there are two people who are going on a motorbike. The person who is sitting at the back seat is sometimes carrying a very broad cardboard like object, or sometimes people carry even plyboards also on the two-wheelers when they are traveling in two-seated vehicles. So just imagine the situation if you have ever experienced. It's very difficult to hold that plyboard or even a cardboard if you are holding sitting at the back seat of a two-wheeler, because the air which is coming from the front, it makes the motion very difficult if the area of the object is very large. If the area is very large, then the viscous drag offered by the air is also fluid air, I mention it once again. So the drag offered by the air is very large. But if the shape of the object is somewhat like this, has the shape of an aircraft, this kind of a shape is known as streamline. So if the object is streamlined in shape, then viscous drag offered to the object is very less as compared to the objects having a broader shape. Broader shape अगर होगा, चौड़ा shape होगा तो उसके ऊपर fluid friction ज़्यादा लगेगा. But if the shape is streamlined, then the viscous drag will be less. Now, why this is known as streamline? This is also because of a simple concept that the fluids, if you cannot see a fluid, for example in air, we cannot see air, but we can imagine that air is made up of some lines which have some particular direction of flow. We call these lines as streamlines. Streamlines are those lines which are moving with a constant speed in a particular direction without any kind of, at a very slow speed and without any kind of mixing of the layers. So if the object is made in the shape of the stream, then it is known as streamline, and we have seen that we have learned the streamlining shape from the fishes which move in the water. Their bodies are streamlined and they are able to swim through waters very easily because of the shape of their body. And looking at the shape of the ships, we are able to design the boats and the aircrafts so that the fluid friction experienced by them is minimized.